Assalamu alaikum and very good evening to all of you. I hope you had a very good day so far. My dear followers, students, and colleagues, in this video I am going to use some of the mathematical concepts that are widely used in microeconomic theory, especially in consumer theory as well as in the theory of production. So let me start with this background, and here I am going to explain upper contour set, lower contour set, uh, level curve, and level sets, and some other concepts like vectors and so on. So let me start with level set. A level set of a function f consists of all the points in the domain of function at which the function takes a certain value. In other words, take any 2 points that belong to the same level set of a function f. This will mean that f assigns the same value to both the points. For example, if we draw an indifference curve, then the indifference curve passes through various points, which gives the same level of satisfaction to the consumer. So all these points through which this indifference curve, which is also known as the level curve or level set, assign same value to all these points. A level set of a function of two variables, that is a function of x and y, is a curve in the two-dimensional xy plane called a level curve, just like I gave you example of the indifference curve. That is a level curve. If we have a level set of a function of three variables, that is function of x, y, and z, then it is a surface in the three-dimensional space, and that is known as a level surface. The level set of a differentiable function f that is mapped from dimension Rn into R corresponding to a real value C is the set of points x1 up to xn in Rn such that that function is equal to C. So that set is known as the level set. For example, the level set of the function f of x, y, and z, which is equal to x square plus y square plus z square corresponding to the value C, is the sphere x square plus y square plus z square is equal to C, with center 0, 0, 0, and radius as C under square and under root. If n is equal to 2, the level set is a plane curve known as a level curve, just like an indifference curve or isoquant. If n is 3, the level set is a surface known as a level surface. Level sets that we know by other names include indifference curves, isoprofit lines, budget line, isocost, the production possibility frontier, and so on. Now I'll explain upper contour set and lower contour sets. An upper contour set of a function f consists of all the points in the domain of the function f at which the value of the function is at least a certain value. We talk about the upper contour set of a function f corresponding to alpha, referring to the set of points to which this function f assigns the value at least alpha. A lower contour set of a function f consists of all the points in the domain of the function at which the value of the function is no more than a certain value. In order to understand the concept of lower set and lower contour set and upper contour set, I'll give you example. of these two graphs. The two curves resemble, they are more or less the same, but the two curves are only identical in the shape except for the labels. The labels of these two diagrams or these two figures are different. Excuse me. But the interpretation of the two curves is exclusively different. They are not exactly the same, they are totally different. So on the left side, we have a graph of a function of one variable, where along the vertical axis we measure y, which is a dependent variable, and along the horizontal axis we measure x, which is independent variable. So this is a graph of the function of one variable where y is a function of x. In this figure, this area in the northeast of the line is the area above the graph, and that is called epigraph of the function. Whereas the area in the southwest SW of the line is the area below the graph, and that is known as a hypograph of the function. Now, the figure on the right hand side is a bit different as compared to this one. Here we have two goods. X1 good is measured along the horizontal axis, and X2 is measured along the vertical axis, and this is a function of two variables. Say for example utility function, where it depends upon x1, the quantities of x1 and x2. So this is a level set. As I mentioned earlier, this is a kind of a level set of a function of two variables. Now the area in the northeast, that is above this indifference curve or above this line, is known as the upper contour set of the function. So area above this indifference curve in the northeast, that is the northeast, that is known as the upper contour set of the function. On the other hand, area in the southwest, that is area below this indifference curve or this level set uh, of this line, is a lower contour set of the function. So this is how we define upper contour set and lower contour set, and these should be not confused with epigraph and hypograph. So in this case, the two-dimensional picture represents the domain of the function. The height of the function is not drawn. Furthermore, there are some familiar examples of level sets and contour sets in economic theory, and level sets that you know by other names are like indifference curves, as I mentioned earlier, isoprofit lines, budget line, and the production possibility frontier. Lower contour sets that you know by other names include like examples of the budget sets, that is the area below the budget line, the production possibility set, that is points below the production possibility frontier in the xy plane in two-dimensional diagram. Then upper contour sets that you know by other names, you may think of the region of comparative advantage in the Edgeworth box, and this is the intersection of the upper contour sets of the two traders utility function. You may remember that from the basic microeconomics or introduction to microeconomics, in which we discuss the indifference curves of the two consumers and two goods. As I mentioned earlier, again, this is the graph. This is a good one. This is good too, and this is the level curve or an indifference curve. So all points on this curve are shown by u naught. These are the function of x1 and x2, and this line shows various combinations of x1 and x2 which give a given level of satisfaction to the consumer. And this shaded area above this indifference curve shows basically the upper contour set of this function. So this is how we explain upper contour set. Similarly, the area below this indifference curve, that is to the southwest, constitutes the lower contour set of this function. Mapping is another concept that is used also in advanced economic theory, and it is a mathematical relation such that each element of a given set, that is the domain of the function, is associated with an element of another set, that is range of the function. If you look at this figure, this there are a number of elements a, b, c, and d, and these are in the domain of the function, and these are associated with some other elements in another set, which is known as the range of the function. So this is a kind of mapping from the domain to the range. A function is a special type of relation in which each element of the domain is paired with exactly one element in the range, as in this case each element in the domain is paired with exactly one element in the range. So this kind of relation is known as a function. A mapping shows how the elements are paired. It is like a flow chart for a function showing the input and output values. A mapping diagram consists of two parallel columns, just like this. The first column represents the domain of the function f, and the other column represents a range of this function. Lines or arrows are drawn from the domain to the range to represent the relation between any two elements. A function represented by the mapping above, in which each of the element is paired with exactly one element of the domain, is called one-to-one mapping. So this is one-to-one mapping, but it is not necessary that always there will be one-to-one mapping. There may be many to one or one to many. So let me also discuss those two. Here in this figure, the second element, that is this one, associates with the more than one element in the domain. This element have mapped with two different elements in the domain. If the elements in the range that have mapped more than one element in the domain is called many to one mapping. So this is many to one mapping. On the other hand, in another mapping, that is in this mapping, the first element of the domain have mapped with more than two elements in the range. If one element in the domain is mapped with more than one element in the range, then the mapping is known as one-to-many relation. One-to-many relations are not functions. So this is not a function, this is not a function. After this, we will discuss vectors. So a question is, what is a vector? A vector is an object that has both a magnitude and direction. That is, it has a size and a direction. So vectors are widely used in mathematics, and we also use them in consumer theory, and these are the objects which have both magnitude and direction. Magnitude defines the size of the vector, and it is represented by a line with an arrow, where the length of the line is the magnitude or size of the vector, and the arrow shows the direction of the vector. It is also known as Euclidean vector, geometric vector, spatial vector, or simply a vector. The direction of the vector is from its tail to its head. We may recall that a vector in n-dimensional Euclidean space is an ordered collection of n scalars, you can say ordered n tuple. For example, a vector x is like it includes various quantities of these goods. X1 is quantity of x1 good, x2 is the quantity of x2 good, and finally xn is the quantity of the good n. A vector in R2, that is in xy plane, is often depicted as an arrow. Here is the vector notation. For example, we have 2 points B and A. As we know already, a vector has both magnitude and direction. In this figure, the length of the line AB is magnitude and head of the arrow points towards direction. Therefore, vectors between 2 points A and B is given by this AB vector. This is the sign for the vector, or vector A. We also call this vector A. The arrow over the head of the vector shows the direction of the vector. I hope this was informative and helpful for you. Kindly subscribe to the channel and don't forget to click on the bell icon so that you can get regular notifications about other videos that will be uploaded for you. Thanks for watching this video. Kindly share various videos of this channel in various WhatsApp groups so that this could reach to the maximum possible number of people.